Okay, I'll be sketching the graph of x plus x times the square root of 2 plus x. First step I found the domain. Any value less than -2 does not exist. But every value from infinity onward does exist. So the domain is -2 to infinity. To find the y-intercept, you set x equal to 0, and you get the point 0, 0. 0 times the square root of 2 plus 0 equals 0. X-intercepts, I did it with logic, I guess. If the x equals 0, you get a 0 value for y. If x equals -2, you get a 0 value for y. So the x-intercepts are 0 and -2. Then I took the first derivative. I used the product rule, so you get first times the derivative of the second plus the second times the derivative of the first, which ends up equaling x times 1 half times 2 plus x to the -1/2 power plus 2 plus x to the 1/2 power times 1. When combining these terms, I got a common denominator, so I multiply the top and the bottom by 2 of the second term by 2 times the square root of 2 plus x. This makes the top square root cancel, so you end up getting x plus 4 plus 2 times x, all over 2 times the square root of 2 plus x. If you simplify, you get 3x plus 4 all over 2 times the square root of 2 plus x. For the first derivative, where f of x, the f prime of x equals 0, is where you'll get a critical value, a switch from increasing to decreasing, or where it does not exist. So setting y prime to 0 is when you've taken the numerator equal to 0. So you get 3x plus 4 equals 0. X must equal -4/3, or 1 1/3, to give a critical value for the first derivative. For doing the do not exist test, you get the bottom equal to 0, which is 2 times the square root of 2 plus x. The only thing they'll give you is 0 is a -2, so x equals -2 is another critical value. After that, I did the sign test to determine what part of the graph is increasing or decreasing. My points are the beginning of the function at -2 because it's the first part of the domain, and then the one critical value, which is -1 1/3 or -4/3. I found a point in between the two, -1.5 or -3/2. By plugging that value into 3x, and the two factors that we're testing are 3x plus 4 and 2 times the square root of 2 plus x, the numerator and the denominator. When plugging -3/2 into 3 times x plus 4, you get -9/2 plus 4, which is also equal to -4.5 plus 4, so you get a negative value. In the numerator, you get 2 plus a value less than 2, which is positive, times 2, which is positive. So you get a decreasing function from -2 to -4/3. Then when you plug 0, which is what I took from my other interval, into the value, you get 3 times 0 plus 4, which is positive, or 2 times the square root of 2, which is positive. So you get a local min at the value -4/3. I over here, to keep it notated, I got a decreasing on the interval of -2 to -4/3, and increasing on the interval of -4/3 to infinity. Now to find the parts of the graph where it's concave up or concave down, you have to do the second derivative. I use the quotient rule for this part. So I get bottom times the derivative of the top, which is 3, minus the top, which is 3x plus 4, times the derivative of the bottom, which is 2 plus x to the -1/2 power. Bring the 1/2 in front. and the 2 from the previous. You get the 2 from the denominator of the previous, and you get the 1/2 from bringing the 1/2 in front, taking the derivative. Those two end up canceling, and you get it all over the bottom squared, which is 2 times the square root of 2 plus x squared. I factored out a 2 plus x to the negative 1/2 power out of this equation, which leaves you with the 2 and the 3 combined gives you 6. Take a negative 1/2 out of 2 plus x to the 1/2 power, you get a 2 plus x. Minus, I distributed the negatives, so you get minus 3x minus 4. I took the 2 plus x to the negative 1/2 out, so this is 1, and the 2 and the 1/2 cancel, which is 1. All over the bottom, which I distributed, so you get 2 times 2, and you get 2 plus x, the square root of 2 plus x times the square root of 2 plus x, so you get 4 times 2 plus x equals, I canceled the top, the thing I factored out. I actually moved the thing I factored out to the bottom. So you get 3x plus 8 all over 4 times 2 plus x times the square root of 2 plus x. The factors that I got for this are 3x plus 8, 2 plus x, and the square root of 2 plus x. By plugging these, and then to find the points where I'll have a critical value, I set the top to 0. Y double prime equals 0, which equals 3x plus 8 equals 0. You end up getting x equals negative 8/3, which isn't actually in your domain, so you don't even have to worry about it. So I just found one value from negative 2 to infinity to test. And by testing 0, you get positive on every value, so it's concave up from negative 2 to infinity. No points of inflection. Using this information that we had in the previous sheet of paper, we get our y-intercept at 0, 0. We get our x-intercepts at x equals 0 and x equals negative 2. Our domain is negative 2 to infinity. Our local min is at x equals negative 4/3. It's increasing from negative 4/3 to infinity. It's decreasing from negative 2 to negative 4/3, and it's concave up from negative 2 to infinity. So I got the value at negative 2 where our graph starts. It decreases down to the local min at negative 4/3, then increases, keeping concavity of upward the entirety of the graph. Thanks for watching.